Alright, so I'm testing Tesla's one-wire transmission principle, and again that's what led to his world wireless system. And so I gotten better results with everything, made a little bit more efficiency. It's not, I mean, it still could be improved so much more, but so here we go. So, you know, I have that high voltage transformer going to capacitor type spark gap device. I tried using higher voltage capacitors, but they don't allow the buildup of energy, and it short circuits this because it's just a small device. And so what happens is that, you know, this capacitor type spark gap thing makes the capacitor effect on it, and also discharges through itself, and you'll see a plasma form on it. And I'm sure it's giving off a lot of ultraviolet light. And so, you know, tomorrow morning when I wake up and go to work, I'll probably have a tan. But you know, so it goes to a primary, and then this primary excites the secondary. And look, I didn't put the capacitor top, so you can kind of see that you don't need it yet, but I mean it does affect it. And this is such a low voltage anyways that it kind of is different on its, you know, on its own. And so I was kind of showing this to the capacitor. I was trying to have it excite the circuit, but you know, nothing happened, and it caused the transformer to short circuit itself and turn off. So it didn't really do much. And so now from the whole device, like I was showing before, you have a one wire, and one wire can go all the way, and I'll show this light up, and look, a capacitive end on the end. So let's get to work and let's show this thing. And so, you know, I'm plugging it in, you know, and once you plug it in, you'll see that plasma form on it, and everyone wanted to see the plasma, so that's what it looks like. But now let's look at the whole coil. Now electricity is going down the wire, and if you look, you can see that it's lighting up here. And you can also see now this. Watch, if you take it off, look at, you can show it's like a passive effect, you know, right there. Watch. Isn't it interesting that you can make an effect like that? And so there's that plasma effect. It's probably gonna have a ton of ultraviolet. You can smell the ozone in a potent amount. And so here's another thing: is people have like looked at this and didn't really understand this. We'll talk this as a capacitive type effect going on. And what you're doing is you're helping excite the bulb by making a surface area near the bulb. He's showing also metal pieces that were near the bulb and would help excite it more than what it is. And so you can see that. And then if you push this wire close to it, oops, shoot. So you can see electricity on there on the bulbs. And now if you come down here, here's the awesomest part. Look. Got a fluorescent tube lighting up. And so what you're seeing here is the electricity just going down the fluorescent tube. And what's interesting, you can make a change on this tube too. You can't really see it in the video, but I'm changing the light going through it a little. And then when you come on here is the capacitive terminal, and if you look again, there's electricity on this terminal. And watch, ooh, the light just burnt out. So as you can see, it doesn't last too long. But it was good. At least I was able to show you everything. And I'll go reset the whole device again and show this again. This is using the long wire as the capacitive spark gap type thing. Let's turn it on. And that's the light I get. You can almost see that lighting up on this bulb. Capacitive effect. Everything's a lot weaker with the longer one. Now it's half the size. You see the energy is increasing. On energy that goes down the wires. And even another demonstration. Now you got two bulbs lighting up. can also start seeing the plasma effect on the wire. So it kind of shows like some type of resonance effect, I guess. Capacitive effect should be strong, right? Yeah. That's strong. Now I took 1/4 off of the last length of wire. It was about a foot long. So then I'll see how bright the bulbs get. Actually a lot more brighter, but also it's a lot more purple on the wire. Let's get a close up. And the wire is probably going to burn out because it's hot right now. You can see. See the capacitive nature of my hand. The bulb is lighting up in the dark. Alright, I just want to show one more last effect. When you start doing this, Tesla even said this in the bulb research that he did, that some of these bulbs, if you put your hand next to them, you'll feel like an effector on the bulb, and it feels like the vibration. And when you put your fingers really close to it, you feel that vibration on your skin, and it's just another interesting effect. So I'll just turn it on really fast and show you that. So if I put my hand on there, you get this like electrical type vibration. It feels really neat. It's neat feeling that you feel. Look at the bulbs changing, going back and forth. Now I took 1/4 off of the last length of wire. It was about a foot long. So then I'll see how bright the bulbs get. Actually a lot more brighter, but also it's a lot more purple on the wire. Let's get a close up. And the wire is probably going to burn out because it's hot right now. You can see. See the capacitive nature of my hand. The bulb is lighting up in the dark. Alright, I just want to show one more last effect. When you start doing this, Tesla even said this in the bulb research that he did, that some of these bulbs, if you put your hand next to them, you'll feel like an effector on the bulb, and it feels like the vibration. and when you put your fingers really close to it, you feel that vibration on your skin, and it's just another interesting effect. So I'll just turn it on really fast and show you that. So if I put my hand on there, you get this like electrical type vibration. It feels really neat. It's neat feeling that you feel. The bulb's changing, going back and forth.